Thank you. Um, so my name is Christina, and I'm from Vancouver, Canada. My research topic is on katabatic winds in Antarctica under the mentorship of Cécile Defranche. Katabatic winds, also known as downslope winds or gravity winds, are one of the fiercest winds on Earth. In my research, I'd like to find out why these winds are so extreme and in which regions of Antarctica possess the strongest ones. Winds, basically, in a nutshell, are airflows created from a pressure difference in the atmosphere. This pressure difference can be caused by temperature difference, which is what happens in very cold regions like Antarctica and other polar parts of the world. Katabatic winds are winds that form in the presence of a cold surface and a slope. Because the surface of this continent is so cold and covered with snow, the area is very prone to stuff like katabatic winds forming. On this wind map, we can see that the movement of the wind, as shown by the arrows here, generally travel towards coastal areas. You can also see that there are black outlines on the continent, which denote the topography of it. Each line represents a different level of elevation, which means that the land near the coast is significantly steeper because it has more lines than the land in the interior. So on Python, we have plotted histograms of the wind distributions at 4 different stations: Dumont d'Urville, D47, D85, and Dome C. All of these are in one region of Antarctica called Adelie Land, which is a claimed territory of France. These graphs have what we have fitted known as a Weible distribution. You can see from the black lines. The Weible distribution is basically what gives us the variability of wind speed in a value called kappa. The kappa is the K that you can see in each legend here. And a larger kappa value signifies a lower variability in wind speeds, and this is what we consider proof of katabatic winds. Now I have transferred each kappa value into a chart for easier comparison, and we can see that D47 has the largest kappa value out of the 4 locations. This means that D47 has the greatest presence of katabatic winds, and this makes a lot of sense because if we look back at the wind map, D47 is in a much steeper area than, say, Dome C. And while because slopes are one of the criteria for the creation of katabatic winds, this definitely is what is reflected in real life. And so, although this wasn't really my first research, this experience was definitely a new one, and it incorporated a lot of things that I probably didn't talk about earlier. I curated a glossary document that detailed definitions of scientific jargon or vocab, and I also learned Python. My mentor made me a workbook on Google Colab to serve as an introduction to the language, and I eventually computed my own graphs using the given data. This part was probably the most difficult aspect of my research, but I was able to tackle these obstacles through resources such as consulting my mentor, online resources such as Stack Overflow, and just tinkering around with my code. I found that sometimes things just click and you find where it went wrong. And my mentor, Cécile Defranche, she is a PhD student at the Laboratoire des Sciences du Climat et de l'Environnement in France. She's not only very, very knowledgeable in her field, but she was able to teach me very complicated ideas in an easily comprehensible way during a short amount of time. She also introduced me ways to pursue climate science in the future, and this included various post-secondary options as well as a plethora of professions out there. I'd like to acknowledge her for her incredible guidance and unwavering support through this research. None of this could have been done without her. I'm very grateful to have been paired with such a phenomenal mentor, and thank you for listening.